Hello friends, welcome to my channel RGCS Revision and Notes. Today we'll see August 2024 Computer Science paper. We have already covered TOC, Computer Networks and Operating Systems. You can check out the links in the description. Now we'll continue with the next unit, that is the Computer Architecture. So here are the problems. A multiprocessor system with 16 processes is used to execute a parallelizable task if the serial portion, here it is the serial portion, okay, if the serial portion of the task takes 200 clock cycles and the parallel portion takes 800 clock cycles. When all 16 processors are used, how many clock cycles are required to complete the task? Now, if you take the serial portion of the task is given as 200 cycles, so serial portion will take the 200 cycles, so it cannot be skipped. So 200 cycles have to happen. The parallel portion of the task has 800 cycles. Here, this can be divided among the 16 processes. So here they ask the total number of clock cycles. So total number of clock cycles will be that 200 cycles, that is with the serial, and the plus the parallel portion will take 800 cycles, that divided by the number of processes, that will give you 800 by 16, which is equal to 200 plus 50, which is equal to 250. So the total number of clock cycles is 250. So the answer is option 1. The correct answer is option 1, that is 250. Question number 29. A CPU has a 5-stage pipeline with the following stages: fetch, decode, execute, memory, and write back. Each stage takes 1 clock cycle to complete. Assume there are no pipeline stalls and pipeline is initially empty. How many clock cycles are required to complete the execution of 10 instructions? In a 5-stage pipeline, here each stage takes 1 clock cycle. So number of instructions are given as 10. So one instruction has to go through the 5 stages, and as each stage takes 1 clock cycle, so it is in the pipeline, the first instruction alone will take that 5 clock cycles. So 5 into 1 clock cycle, this is 5 clock cycles. Then the remaining 9 instructions will be executed in the pipeline. So this can happen in how many cycles? It can happen in 1 cycle, sir, because it is going in the pipeline. Hence, one instruction takes only 1 cycle. So 9 instructions will take how many cycles? 9 into 1 clock cycle, which is 9 clock cycles. Therefore, the total number of cycles required to complete the execution of 10 instructions will be what? It will be 5 clock cycles plus these 9 clock cycles. So 9 plus 5, which is equal to 14 clock cycles. 14. Question number 90. A vector processor with 16 lanes can perform an operation on 1024 elements, with each operation taking 5 clock cycles. How many cycles are needed to complete the operation? See, vector processors implement an instruction set. So vector processor means they execute an instructions set on large one-dimensional arrays of data called vectors. So here there are 1024 elements with 16 lanes. Okay, and each operation will take 5 clock cycles. So you divide 1024 by 16, you get 64 clock cycles, because 16 lanes will perform operation on these 1024 elements. So you have 64 clock cycles. So the answer to this problem is 1, which is 64 clock cycles. Friends, this question paper, this is August 2024 paper, is available in the official website, that is NTA website. So now we'll move on to question number 93. Arrange the given steps required for a direct memory access transfer in the correct order. So A, initiate DMA transfer request. B, transfer data directly between peripheral and memory. C, processor grants DMA control over the system bus. D, DMA controller completes the data transfer and signals completion. What is DMA? DMA is direct memory access. So it is an interface between the memory unit and the peripheral devices. So what does it do? It transfers the data in and out of the memory unit through the memory bus. First, what it will do, it will first initiate the DMA transfer request. Next, it will the processor will grant the DMA control over the system. Then the transfer of data takes place between the peripheral and memory, and then the DMA controller will complete the data transfer and signal completion. So that is what is given here, the options. So first it is A option, that is initiating, and then C processor grants the DMA control, and then B, the transfer of data takes place, and D, finally DMA control completes transfer and signals completion. So the correct option is A, C, B, D, and the option is 2. Correct option is 2. Next question number 95. Find the current sequence of the storage device in ascending order based on the access time. So the given registers, magnetic disk, magnetic tapes, main memory, optical disk. This is a drop question because they are not arranged in the correct ascending order. So actually the ascending order means which is the having the shortest access time. So which will have the shortest access time? So you see from registers and main memory, registers will have the shortest time, that is A is the will have the shortest time. So A, that option will come first, but here none of the options is coming having A as the first, so that's why it's a top question. Actually this is the correct order, that is A should come first, and then D, that is the main memory. Next it is having more speed. Next B, that is the magnetic disk, then E, that is the optical disk, and then C, that is the magnetic tapes. Take this is the correct answer, but in the reverse order. So friends, we have solved 5 problems so far from the computer architecture unit in the August 2024 computer science paper. I hope this was useful to you. We'll cover the next 5 problems in the next video. If you need any notes on the questions and answers, I have PDFs. Please write to me in the comment section. If you need this, I shall provide you. We'll see in the next video. We'll continue with the computer architecture remaining 5 problems. Please do like, share and subscribe my channel so that it will be a motivation for me to do more useful videos. Thank you.